Scientists aboard the M3 lab were puzzled by the second-order differential equation with some x's as the coefficients. Well, if we were to assume that we had some solution of y equals x to the power of m, then we would be able to start taking derivatives here. So we could say that the first derivative is going to be like mx, and then we have m minus 1. The second derivative is, well, now we would have m minus 1 with our with our x here to the m minus 2. Well, if we started to plug in these second derivatives and the first derivative and then the y over there, we would be able to simplify all this. And let's keep note that we could replace some coefficients here. So let's say we know that a here, like a is going to be 1, and b, the coefficient in front of this, is also 1. And here the c coefficient is going to be like -4, right? We could think about it like that. But if we were to use a, b, and c instead of those numbers, and then we were to solve all this, we could reduce it to a form of the quadratic equation, which would be something like am squared plus, we have b minus a, and then there's an m, and then we have plus c, and that's going to equal to 0. So that's what happens if we just use a, b, and c instead of 1, 1, and -4, and we plug in y, y prime, y double prime into these, and simplify all this, it becomes this equation here. So let's try to replace our coefficients in here. We basically have, if a is 1, then we just get an m squared. Then we have b minus a, which is 1 minus 1 is 0. So that basically gets rid of that middle term. And we're just left with the c over here, which is -4. So m squared minus 4 is going to be equal to 0. That's sort of the quadratic equation that now we have to solve. But we can clearly see that if we have m minus 2 and then m plus 2, that will give us m squared minus 4. Okay, so if that's the case, then we can say that we have m1 being equal to 2 and m2 being equal to -2. Now, if we go over here, we could see that we could just get a y1, which is going to be equal to x to the 2, and a y2, which is going to be equal to x to the -2. And considering that this is a homogeneous equation, which is equal to 0, then we know that yh is essentially going to be equal to c times this one and c times that one. We'll say c1 times x squared plus c2 times x to the -2. And now we have our answer to this equation here. But what if this was a +4 instead of a -4? If that were the case, then we'd still end up with the same situation after we plug in all this. We get a m squared plus b minus a m plus c equals 0. And then we just plug it in for our a, b's, and c's, which here in this case we know a is still 1, b is still 1, and c is actually 4. So when we do this part, we get something like m squared plus 4 equals 0. And if that's the case, we get that m squared equals -4. And that means that, well, m1 is going to be equal to 2i, and m2 is going to be equal to -2i, because essentially we have the square root of -4 on that side. And, well, that means that y1 is going to be equal to x to the 2i, and y2 is equal to x to the -2i. But we don't really like seeing this kind of stuff. So if we see that, then let's consider we could put e to the ln of x to the 2i. We could just do a little bit of a replacement here because these things cancel each other out. And then we'll sort of move the 2i in front here. So we'll have something like e 2i ln of x. So you could think of this as being e to the 2 ln x with an I here. And we know from the e to the I theta thing that it's supposed to be equal to cosine theta plus I sine theta. And here, we'll basically be putting in cosine of 2 ln x plus the I sine of 2 ln x. And And this is supposed to be for like y1. So this is one of the y's. And since we have two of those y's, we'll end up with like y2 is going to have the same type of stuff. It's going to be like 2 ln x minus I sine 2 ln x, if we do it for the other one. And these are just going to cancel each other out, essentially. So that way we get a y, homogeneous y, which is just going to be equal to c1 times cosine of 2 ln x plus a c2 times a sine of 2 ln x. And that is our homogeneous function from adding those two together, which we can then sort of return back to this and sort of base. Well, our answers there should have really been cosine of 2 ln x and sine of 2 ln x. So this is the answer for this one. And this is some interesting stuff.